So if you have a straight line and you want to know the slope, you get 2 points. You do y2 minus y1 over x2 minus x1, you know the slope. But when you have a curved line, in fact, the slope at any point on the graph is changing, right? And rate of change is a pretty important concept in physical sciences. You want to know how things are changing. And so like the line, this tangent line here to that point on the graph, that would have the same slope as that graph does just at that point, right? It would be different to the right or to the left, but at that point, whatever the slope of the tangent line is, that's the slope of the graph, right? This would be a positive slope, negative slope, zero slope. Again, if I wanted to know the slope of any of those tangent lines, what do I need? 2 points, right? 2 points. Well, let's say that I wanted to find the slope of this graph at this point. Let me change my color. Okay, then what I can do is I'm going to take 2 points. Here's 1 point and here's the other point. And I can draw a line through it. I can calculate the slope. Will it be a great approximation of the slope? Not great. What happens if I let that point get closer to the first point where I'm trying to find the slope? Right? I move this point, move it down a little bit better. Right? If I let the points get even closer together, a little bit better still. Okay. What if I let that point get, even like right there? Then the slope of that line would be pretty darn close to the slope of the graph at that point. So the closer I let those 2 points get together, the better is my approximation. Can I ever let those 2 points actually come together? Right? In terms of like the slope formula, that's like saying x2 minus x1, but they're the same point, which means you're dividing by 0. In terms of this, right, we're calling this point x, f of x, and this point, the distance between here and here in the x direction is h. So when you do the x2 minus x1, you just get h. Right? So this point is f of x plus h, f of x plus h. That's like y2 or x2, y2, x1, y1. When you put it in the formula, you get this. A lot of this stuff is actually conjuring up things we did in the very beginning of the class. That's called the difference quotient. Okay, but we would like to see if I calculated the slope there, and then I calculated the slope there, and then I calculated the slope there, and then maybe even there. Maybe I could look at those slopes and see whether it looks like they're approaching some number, right? If they did, then that might be the slope at that point when I actually get there, if I ever could, which I can't. Right? So that's one